Hey you guys, this is the formula we learned for interest, compounded interest. R stands for the rate, just make sure that it's in decimal form, okay? And it stands for the annual rate that's compounded once a year, annually. In this problem though, it's compounded quarterly. So that means you have to take that and divide it by 4, right? The amount that you end up with is this. Principal is what you're looking for. And the rate is that divided by 4. Now, T in our formula stands for how many times the interest is compounded total, right? So if for 6 years, every year it's compounded 4 times, that means altogether it's 24 times. So you don't have to put that in your calculator yet, right? You're looking for P. So divide by this on both sides. Okay, and then put that in your calculator and see what you get. So whatever, yeah, I don't have the answer now. I don't want to stop the video to get the answer. This is a calculator thing. You should be able to do it. We'll check it in class tomorrow. Just make sure, because it's money, you've got to round off to the nearest cent. So the dollars and the cents here. Okay. In number 2, we went over over this in class. A single logarithm means just 1, right? So you can combine the 3 logarithms. You can't combine logs if they have a coefficient other than 1. So we're going to use the power rule for logs and rewrite this first as log m to the 4th. And this is log n to the 1/2. And this has a coefficient of 1 already. Adding 2 logs means you're multiplying their arguments. N to the 1/2 is square root of n. You could leave it as 1 to the 1/2 if you want it, and divide that by p. So we use the power rule for logs, we use the product rule for logs, and the division rule. Okay, so we have one single log. Number 3, again, you need to combine the logs because you're looking for x here since it says solve. Right? 2 logs are better than 1. No, not really. In this case, 1 log is better than 2 because it allows you to solve for x. So we have addition again. So we're going to multiply the inside, the arguments. Okay. And remember, solving for x means getting rid of everything else around it. So I'm going to get rid of the log first by rewriting this in exponent form. So it's 3 to the 1 equals x squared minus 4x. Okay. And solving this does not factor, so you have to use the quadratic formula. Of course you remember that. If you don't remember it, make sure you put it on your index cards to memorize it, okay? Negative b, that would be 4 plus or minus b squared, which is 16, minus 4ac over 2a. Remember that the a, b, and c are just the coefficients of the equation. A is 1, b is negative 4, and c is negative 3. Okay, so I'm going to continue over here so as not to get into that space. All right, so we have 4 plus or minus 16 plus 12. That's 28 over 2. So it's 4 plus or minus square root of 28. We can factor the 4 out, square root of 4 and square root of 7. So that becomes this, which becomes 2 plus or minus square root of 7, because the 2 goes into both of these. And those are the answers for this. Make sure, though, that when you plug these into here, both of these are still positive, right? So 2 minus square root of 7 is going to be a negative number because square root of 7 is more than 2. So the negative 1 is going to have to be rejected. So the only answer here is 2 plus square root of 7. I should not have boxed that. No box, no box. Okay. Okay. I'm going to do D before I do B since it's right next to it here. Add 10 to both sides. So this side becomes 8, right? Then raise both sides to the negative 2/3 power. 8 to the negative 2/3. Remember, negative just means 1 over. 8 to the 2/3. 3 is the cube root, and 2 is the power. Okay, so add 23. Oh, cube root of 8 is 2. 2 squared is 4, and I'm going to add 23. So x is 23¼ Okay. I'm doing this off the top of my head, so I'm not checking my answers, but if anybody gets different answers, please let me know. Okay. All right. Part B. So this has the construct of a quadratic equation, which means I'll try to factor it. E to the x times e to the x gives me e to the 2x, because remember, you add the powers when you multiply two expressions with the same base. And I need two numbers that multiply to -3 and add up to -1. That would be that. Okay, so e to the x minus 3 equals 0. E to the x equals -1. You know, well, let me be consistent. Plus 1 equals 0. So solving for e to the x, we get that, we get this. This can never be because e is a positive number. You can't raise a positive number to a power and get a negative. There's no solution here, right? This one, though, you have to take ln of both sides because ln is the inverse of e. So ln of x is the inverse of e to the x. So that gives you ln of 3. Box the correct thing. Okay. This one here, again, we write this in power and exponent form to get rid of the log. This is 64 plus 2 equals x. Okay, this is much easier than part A, so I don't know why they put E after A, but whatever. Okay, I'm going to do F next. Take log of both sides. The reason for that is to get x out of the power and make it a coefficient. So if I take logs of both sides, I'm going to be allowed to write this because of the power rule of logs. Right? The power can become the coefficient. So divide by log of 5. Sorry, I don't have an iPad. I'm using my phone. I apologize. And then subtract the 1. So you get log 8 over log 5 minus 1. Whatever that is on your calculator. They'll tell you how to round it if you need to round it. This is another one of those problems where you can write, you could use logs if you want, but 81 is 3 to the 4th. And 1 over 3 is 3 to the -1. But there's already a 4 minus x there. So if the bases are the same, the powers have to be the same. So 4 equals -4 plus x. So x is 8. Okay. I'm going to do a different video for the second page.